All right, I hope you had a good lunch. I hope you're not too sleepy. I'll try my best not to let you fall asleep, but we'll see. All right, so the plan now for this afternoon's class is to talk a little bit about social norms and indirect reciprocity. If you don't know what indirect reciprocity is, you will know soon. Before I go to social norms and indirect reciprocity, I realize I didn't have the time to actually explain to you this figure in the morning talk. So let me just have 5 minutes in which I actually tell you what you missed this morning because I ran over time. So perhaps you remember, like where we stopped is we talked in the morning about direct reciprocity, and we talked about like these extortionate strategies. And I told you a little bit like these extortionate strategies sometimes have problems to evolve. But like a question that is completely independent of whether these extortionate strategies could evolve or not is like how would people play against these extortionate strategies? So what we actually did is we invited people to play a repeated business dilemma, and so they didn't play against each other, they played against the computer program, and the computer program implemented an extortionate strategy. And so this is one example of the kind of data that we got. So the black line is actually the mathematical prediction that you would get from Press and Dyson's result. So this is where the payoffs would need to be in an infinitely repeated game. Obviously, our subjects couldn't play an infinitely repeated game. They only played for 60 rounds. And you see this is what happened. So strong clustering around this line. But this is by itself is actually not a surprise. Like this is a mathematical fact that these points need to be close to this line. What is perhaps interesting is that, you know, like what I told you, the best response against such an extortionate strategy is actually to cooperate all the time. But it turns out none of these participants cooperated all the time against an extortionate strategy. So they really didn't like to be exploited by the other player, and therefore they really didn't like to pay what would have maximized their payoffs. So that's what we have found in this experiment. All right, so now we can actually start with the new topic, which is social norms and indirect reciprocity. Yes? Oh, yeah. Yeah. I mean, whether individuals would ever play an extortion strategy, I mean, that's also a very interesting question, one that we would have loved to explore. We just had this problem that it's always very hard to infer the player's strategies just from the observed data. Like if you run this experiment, what you get from participants is 60 data points, like whether they chose to cooperate or defect. It's not exactly straightforward from that to infer what the strategy is. Yeah. So we haven't tested this actually. Yeah, all right. So this is mostly a reminder. So again, we talk about cooperation, and again, cooperation is this costly behavior that is costly for me, but beneficial to you. Yeah, and as I told you in the morning, like these instances of cooperation are difficult to explain if you think that all we play in life is a one-shot business dilemma. I also told you like there are actually mechanisms that can explain these acts of cooperation, like kinship, for example, or group selection, or punishment, or rewards, and all this kind of stuff. Also, we focused on direct reciprocity, like there are all these different mechanisms that actually can explain cooperation. Now, what is interesting about direct reciprocity is that you really need that people meet each other repeatedly. So if people would only meet once or twice, so in other words, if this delta would be very small, you wouldn't get any cooperation. But now in real life, it's actually quite often the case that you cooperate even with strangers that you don't know and where you also don't expect that you would meet them again. So then the question is, can we explain those instances of cooperation somehow? And one idea, like at least in some examples that might come to mind, the idea is that in those instances, you might cooperate not because you meet this person again, but perhaps you meet the friends of this person again. And this person might tell her friends or his friends, hey, Christian Hilbe, he's a really bad person. Like, you best avoid him. And so if you want to maintain a good reputation, it might make sense to cooperate with a person, even if you know that you will never meet this particular person again. Okay? So this whole talk will be a little bit about social norms to cooperate. Yeah, so let me tell you a little bit about social norms. So obviously there are many kinds of social norms out there, and some of these social norms have nothing to do with cooperation. So for example, one social norm that used to be very strong in Austria is that on Sunday you would go to church. I mean, that has been a while ago, like, I mean, I didn't have to do this anymore. But like, for example, for my grandmother, there was a very strong norm that on Sunday you would have to go to church. And even if you don't believe in God, you better go to church, because otherwise the whole village will talk about you. And perhaps another social norm is like, whenever you get a request to review a paper, I mean, probably you feel some urge to say yes, because you feel this is the proper thing to do, and this is what people should do in this kind of situation. So to make things a little bit more precise, what do I think of what is a social norm for me now? So for me, a social norm is a set of rules that determines how you should act in a certain situation. So this is one aspect of it, like they tell you what you should do in a certain situation. But they also tell you, like, how should you deal with people that don't stick to these norms? Like, for example, like if there's this person in your village that is the sole person that never goes to church, like, how should I deal with this person? Should I still interact with this person, or should I avoid this person? All right, and the interesting thing now is, like, these social norms, I mean, they aren't set in stone. For example, the church example clearly shows that social norms can change in time. And then the question is, like, what are the forces that make social norms change in time? So apparently there is an evolutionary process going on. Like a social norm persists as long as it is stable somehow, as long as it is easily enforced. But once people don't find it no longer profitable to stick to this social norms will change. So, I mean, for us, that's good news, because that means we can use the tools of evolutionary game theory to understand social norms. Yeah, and now a little bit more focused, like instead of talking about general social norms out there, in the following I will talk about social norms that make you cooperate in the prisoner's dilemma. So this is what we will deal with in the following. Oops. Yeah. All right, so I start with one of the first models out there that asked this kind of question. I mean, as usual, the economists were first, but this is the first evolutionary model out there. So the first model, evolutionary model out there, it's called image scoring, and it's again a paper by Martin Nowak and Carl Sigmund. So what they did is the following. So they look at the population, again with some arbitrary size and individuals. And now, like, it's again some stochastic process. Like in each time step, you select two individuals. One is randomly determined to be the donor. One is randomly determined to be the, how do I call it here, recipient. And then the donor can decide whether or not to cooperate with the recipient. And as usual, cooperation here means to pay a cost C, for the other one to get a benefit B. Okay? And the rule is also that all other individuals in the population, like, they are not involved in interaction, but they would observe what happens. All right. And now what happens is, well, if I'm the donor, whatever I decide to do, whether I defect or cooperate, it would affect what is called my image score. So every individual has an image score which is kind of reflecting my reputation. So every time I cooperate, my image score goes up by 1. Every time I defect, my image score goes down by 1. So for those who just like pictures, this is kind of the picture. So here you have a population of 6 individuals. They have different scores. So the blue guys with the 4s, they have a really good reputation. You really like them. The red person with a score of -3 has a rather bad reputation. Okay. And then you randomly pick a donor and a recipient. So here in this case, the donor happens to be this pink individual, which at the moment has a negative reputation. And for some reason, this pink individual decides to cooperate now with the blue individual. And then this would be the updated state. So in the updated state, the pink individual has a slightly better reputation than it had before. Okay, and like you can play this over and over again. Like this is now a stochastic process on your population. Now I need to tell you, like, how do people actually decide with whom they cooperate? So I didn't tell you yet, how do people make these decisions? And in this paper, so in other words, what are the people's strategies? How do they look like? In the paper, like Nowak and Sigmund assume, like, each donor, the strategy would be a variable k, and this k is just a threshold. Like this is my minimum threshold to find your reputation acceptable. So for example, if my k happens to be 3, 4, or 5, I would only, if my k is 3, I would only cooperate with you if your reputation is at least 3, 4, or 5. Otherwise, I defect against you. So this image scoring kind of checks, do you have a good reputation, then I cooperate with you, do you have a bad reputation, and I defect with you. And this K is allowed to change over time. So they would also do simulations, like in these simulations, like players would either play these cooperation games, or they would be allowed to update their threshold K. And to update their threshold K, again, you could imagine a Moran process where one person compares its own long-run payoff to the long-run payoff of someone else. And if this other person has a higher payoff, then I would choose your K instead of my K. Yep. Yeah, I believe they just wanted to have some finite set of possible states. Also, you need to keep in mind, like this was in 1998, computers weren't as good back then as they are now. No, this is actually by intention, and I will explain it now in the next line. So what would it actually mean if you have a K of 6? That would mean you would only cooperate if the other person has a reputation of at least 6. But I just excluded such cases, like no one can have a reputation of 6. So that means such a person would always defect. Yeah. So this is our way how to implement always defect in this strategy set.
And if someone has -5, that person always cooperate.
Yeah, excellent. You just got rid of my next line. So this is exactly what my next line would say. Perfect. Well, here, C and B, they are just, so how it works, C and B are parameters of the game, and then you start this simulation. And then, like, players play against many other co-players, depending on their strategy, which depends on K. And then I might sometimes cooperate with others, sometimes I might defect against others. And then I kind of compute my average payoff over a long run. And then at that point, I might compare my strategy, my K, to your K. And I see that your payoff perhaps you had a smaller K than I had, but you had a much higher payoff than I had. So at that point, I would switch to your strategy. So there are actually two kinds of dynamics going on here. Like a short-term dynamics where we just play the game, given our strategies, given our K, and a slower dynamics where we update our K over time. Does that make sense? Kind of, yeah. So in the long run, like in the short run, everything is determined by your K. Like whether you cooperate or defect, I just look at your reputation. Your reputation is, I mean, you are still a 5. I have a K of 3, so I would cooperate against you. And that's what I would do all the time. So over time, I would collect some payoff. And then, so this is what's happening in the short run. But in the long run, I might think, is my K actually a good choice, or should I choose a different K? And to make this kind of decision, I compare my payoff that I got in the last, I don't know, 100 rounds with the payoff that Supratim, for example, got in the last 100 rounds. And if I saw he got a much higher payoff than I did, but he used a higher K than I did, then I would switch to his K. So there is this kind of evolutionary process, this evolutionary dynamics on top of this game dynamics. Yeah, and so then the question that you could ask, like, so it's hard to do math for this model. So it's hard actually to calculate what are the equilibria and under which conditions and this kind of stuff. So what Novak and Sigmund actually did, they just simulated it. And what they found is that, like in the long run, most people actually choose a K that is negative. So you would actually show some generosity. You would even cooperate with people that have a slightly negative reputation. But also in the long run, like almost instantaneously, everyone gets very high payoffs. So they concluded that image scoring is a really good mechanism for cooperation. If you only need to take into account the co-player's reputation and decide based on his co-player's reputation, and if everyone does that, people naturally learn to cooperate all the time. Okay. Now, I could stop here. Unfortunately, I don't stop. So, oh, Nikhil, you have a question. I believe for this simulation, it might be that I don't remember fully anymore. Like, but that wouldn't explain these payoffs. Like the payoffs must be something in the range. I could imagine that B here is 6 and C is 1 or something like that. Yeah. So what happens here is that the payoffs are close to the maximum. It's not really at the maximum. Yeah, that's right. So the maximum that you could get here is B minus C. And if I remember correctly, B minus C was 5 in this example. It's slightly lower here. That's just the normalized average payoff per round. Yeah, for each interaction that I have, like actually for every 2 interactions, once as a donor and once as a recipient, what is my average payoff? Okay. Yeah, so this is what they found in 1998. Now in 21, there was actually another paper that said, but wait a minute, like image scoring, okay, perhaps it evolves in your simulation, but still I can show it's not an equilibrium. And at least not what we would call a subgame perfect equilibrium. And the reason is, like image scoring requires you, like if I encounter someone who has a bad reputation, it requires me to defect against that person. But by doing so, I actually harm my own reputation. And if my reputation is already close to the other people's threshold, I actually wouldn't like to defect against a bad person because that would hurt my own reputation. So therefore, image scoring itself is not stable. Like if Novak and Sigmund allowed for other strategies that also take into account their own current reputation, then these other strategies could possibly invade. For example, a better strategy than image scoring is usually do like image scoring, but if you realize that your own score is really close to the other people's K, you cooperate anyway. All right, and the major insight from this paper is, like, if you really want to get cooperation going, you should distinguish between 2 forms of defection. Like a justified defection where I defected against you because you really are a bad person. And an unjustified defection where I just felt, I don't want to cooperate. And the idea here is, like, if you see a justified defection, it shouldn't harm your reputation. But if you see an unjustified defection, it should harm your reputation. All right, so the next milestone here in this literature is the paper by Otsuki and Iwasa, and they try to take exactly this idea into account, to distinguish between justified defections and unjustified defections. And so to make the model a little bit simpler, in the beginning, they only allowed for 2 possible reputations. So they didn't have a score between -5 and +5. They only had 0 and 1, and 1 is you have a good reputation, 0 is you have a bad reputation. But now they allow for what I would call more complex social norms. So previously, the social norm was like this: like whenever I see you cooperate, your score goes up. Otherwise, it goes down. It was very simple. Also, whenever I meet someone with a very good reputation, I cooperate. Otherwise, I defect. So it was very simple. So here, the norms, they are a little bit more complex. So let me tell you what these norms look like. Yeah, it looks a little bit complicated. So these norms actually consist of 2 components. The first component is called the assessment rule. So what an assessment rule does, it helps me make moral evaluations about you. Like, for example, if I see a good person defecting against another good person, this assessment rule would tell me what to think about it. Would I now think this person was bad, or would I think this person was good? So for example, here this alpha GCG is what is my opinion about a good person who cooperates with another good person? So what is the probability that I would assign a good reputation to this person? And for example, this alpha GDB means with which probability would I assign a good reputation to someone who was initially good and defected against the bad person? And by the way, this is exactly this case where you might want to take into account justified defection. So the person was initially good, but it defected, but the person that it defected against was a bad person. So you might say, okay, it's okay. That was a justified defection. That should still lead to a good reputation. All right, so this is the first component of such a moral norm. It tells you how you should evaluate others. Now, the second component of such a social norm is called the action rule. It tells you how you should now act if you are the donor. So for example, this beta GG means what should you do if you have a good reputation right now, you meet another good person with a good reputation, should you cooperate or defect? What is the probability that you cooperate or defect? So for example, a quite intuitive thing would be that if you are a good person, your co-player is a bad person, then you want to defect. For example, this could be 0. Yeah.
All observers hold the same reputation about a given.
In this model, yes. Everyone agrees on each other's reputations. Yeah. So in particular, it makes sense to talk about my reputation because everyone will agree on what my reputation is. If you think I'm a good person, everyone in this room will think I'm a good person. Yeah, so in principle, like the first vector has 8 components and 2 possibilities for each component. The second vector has 4 components and 2 possibilities. So in total, there are 4,096 possible social norms to consider. Yeah, and just to give you some examples to get a little bit more intuition of how such norms could look like. Well, for example, one way how you could implement all D, for example, is, for example, in this way. Like all D would then just be the person who thinks everyone is bad. So this would be this first thing, like whatever happened, I think you're a bad person. And then also my action rule would tell me, like whatever I think about you, whatever I think about me, I would always defect. By the way, there are quite a few rules that would actually be equivalent to all D, because if you defect all the time anyway, it actually doesn't really matter which reputation I assign to you. This is unconditional, oh, sorry, this is a typo. Yeah, thank you. Yeah, that's right. So this is unconditional defection, very good. Yeah, here it's correct. This is unconditional cooperation right now. So for simplicity, I just assume that unconditional cooperators always think you're a good person, no matter what you do. Also, I would always cooperate with you, no matter what's your reputation, what's my reputation. And now, a little bit more interesting example, which is sometimes called simple scoring. So simple scoring, so how does it assign reputations to people? You see here the first 4 entries are 1. So what is it that the first 4 entries have in common? They have in common that the action was cooperation. So that would mean whenever you cooperate, I think you're a good person. Whenever you defect, I think you're a bad person. And also the action rule here would say, I cooperate here in the first component and I cooperate here in the third component. So what have these components in common? It's that the co-player is deemed as a good person. So this action rule just tells me, whenever I meet a good person, I cooperate. Whenever I meet a bad person, I defect. All right. Yeah, and now our goal, or the goal of Otsuki and Iwasa, is the following. So out of all these 4,096 norms, can we identify those norms that have the following 2 properties? So the first property that I would like to have is, well, if the whole population adopts this social norm, then everyone will cooperate in the end. So that's just, I mean, we are here in the field of evolution of cooperation. We are interested in cooperation. So this is why we are interested in this requirement. The second requirement is the norm should be self-enforcing. So people actually should have an incentive to stick to this norm. Like even if everyone already adopts this norm, I would not have an incentive to deviate from this norm. So in other words, this norm should be a Nash equilibrium. All right. And so the question is, do these norms exist? And if they exist, how do they look like? Now, before I actually go to the first slide, perhaps let's do a little bit an experiment. Let's see whether your intuitions actually fit what will come out. Simple scoring will not be in this list.
Will not be.
No, exactly for this reason that I told you for why image scoring was a bad strategy. Because simple scoring would always defect against a bad person, thereby hurting its own reputation. So simple scoring doesn't have a notion of justified punishment. All right, so let's test our intuitions. So suppose you see a good person defecting against, cooperating against a good person. What would you think should probably be the new reputation? Good. So I believe there was mutual agreement here. All right, so what happens if now, let's say, a good person cooperates with a bad person? Still good, not good? So it seems there are some disagreements. It's not so obvious anymore what we should think. So let's give this an X. All right, what happens if a good person defects against a good person? Agreement? Yeah. Bad. All right, so what is the last case here? Yeah. Would people agree it's good? Yeah. All right. Not good? Perhaps good. X. Somewhat mixed opinions about this. All right, what are the other 4 cases? I promise to be quick. So bad cooperates with good. Yeah, so there should be some redemption. Like even if you were bad in the beginning, like if you cooperate with a good person, that probably should be a good thing. Now the next thing is bad cooperates with bad. Okay. I heard mixed opinions, so let's say X. Now, if bad defects against a good person. That's as bad as it gets, apparently.
So in that case, it's good.
Yeah. And the last case is bad defects against bad. Is this a good thing or a bad thing? Yeah. All right, so I guess what I hear here is an X. And so this is what our intuitions would tell us, apparently. Now, if I might slightly correct our intuitions, I want to get rid of this X. I'm really sorry. We really want to get rid of this X because, like, good needs to be allowed to defect against bad. Like, you need really this way to punish someone who really deserves it. Yeah. I mean, the point that I want to make is, okay, so we actually agree on most of these things. There are actually 3 positions where we disagree, or where we are not exactly sure. So this would suggest it could either be good or bad. So this could be either good or bad. This could be either good or bad. This could be either good or bad. So with our very simple heuristics, we would say there are probably 8 good strategies, 8 strategies that we would think make sense. Yeah, and now comes the result. Yeah, so so what you find if you do it analytically, not with simple intuitions and standing on a blackboard and asking stupid questions, but rather like if you do a mixture of analytical methods and then numerical computation, you come up with exactly 8 social norms that satisfy these 2 properties. So there is a sustained mutual cooperation and they are stable. And if you look at this assessment tool, I'm sorry, I believe I did it a little bit in the wrong order, but you see exactly what is matched by our intuitions. So the reason why there are 8 successful social norms are here is exactly the same reason why we have 3 X's here, because there are 3 situations in which it's not clear what the social norm should tell you, but in all other cases, it's very clear what the social norm should tell you. And so what is it that the social norm should tell you? So what is the shared characteristics of all these assessments, of all these social norms? So the shared characteristics is, like, if I cooperate with a good recipient, that should always be considered as good. Another characteristic that all of them have in common, so if you defect against a good recipient, that's always bad.
Of course, conditional on our goals, which are cooperation and stability.
That's right, yeah. I mean, I use here very moralistic language, but perhaps I shouldn't. So this is just what comes out here. Like, given our goal that we want to sustain full cooperation, these are the successful norms. These are the properties.
It's good, and you can see most people kind of want that intuitively anyway, because they're answering.
That's right, yeah.
Even though they probably not everyone knows.
That's right, yeah. So this exercise could have gone horribly wrong, but by now I have some confidence that I get the right kind of result. If I have the freedom to push you in certain directions, even if there are certain disagreements, I believe, about this thing here. Yeah.
So I believe that part is coming from that part, like where you mentioned that how society should behave with the defectors.
Yeah.
So that part, I think, so to sustain like something for the corporation or
That's right.
stability, we need that those who are not following should be.
That's right. That's right. So that's the reason why it comes out here. But obviously, like, I do understand why you might dislike this. So I do fully understand that you might consider this actually as a bad behavior. Like, I fully understand that you have this kind of social norm that people just shouldn't defect. And but obviously, like, if the norm is to be stable, you really need this component. All right, and the last component is the one that we just talked about. It needs to be true that if a good donor defects against a bad recipient, it doesn't harm the good donor's reputation. All right, and there are 3 points in which these norms disagree. So it's not clear if a good donor who cooperates with a bad recipient, is this good or bad? I don't know. If a bad donor cooperates with a bad recipient, is this good or bad? You could see it either way. And if a bad donor defects with a bad recipient, it could be good or bad. You can see it either way. All right. Yeah, also, like, again, you could now do evolutionary simulations. So this is actually a static result. It tells you something about stability. But again, you could do evolutionary simulations in which just there are populations and they can choose their own social norms. And then you let these social norms evolve. Usually, if you do these if you do these simulations, a strategy that comes quite often on top is called stern judging, which is L6 in this list. And stern judging works as follows. Whenever I see a good person, I really have to cooperate. Whenever I see a bad person, I really have to defect. And also, I should only assign good reputations to people who act in that way. Like, if I see you, for example, cooperating with a bad person, you are bad to me. So this is a kind of a very strict social norm. So it's a really black-white. Good person, you cooperate. Bad person, you defect. There's nothing in between. Now, there is a Nature paper out there that actually makes another interesting point. So this social norm does not only have the property that is successful in simulations, it also has the property that is very easy to explain. Like, so what they looked is at like what they call complexity kappa here is, like, if I wanted to express this social norm as some logical string, what you should do when you behave according to this norm, it's very easy to explain. Just cooperate with good, defect with bad, and if everyone does that, then assign a good reputation, otherwise assign a bad reputation. So it's very easy to explain. And also what is interesting is that, I mean, like, you could ask now, okay, like, what kinds of norms do people have? And like, there is some evidence out there that even infants, like 5-month-old babies, play something that could remind you of stern judging. So you might ask, okay, like, how do you experiment with babies? Because especially if they are 5 months old, it's hard. This is the press release that this group produced. It's infants prefer a nasty moose if it punishes an unhelpful elephant. And I guess that gives you an idea of how they have done this experiment. So there was some animal, and then there was some elephant who could have helped but didn't help for some reason. And then there was this moose showing up and hurting the elephant, and somehow they could tell from the infant's face, oh, the infant liked this. Yeah. I mean, I'm not sure how robust this result is, but I find it funny that there are these kinds of experiments. No, I actually believe they did it with acting, so that the caretaker actually had an elephant in the hand and did crazy stuff. Yeah. Oh yes, sorry, I should have explained to you that. So first order is if your social norm only depends on what you do. So, for example, image scoring is a first order norm. Like, if you cooperate, you're a good person. If you defect, you're a bad person. Second order is a norm if it also takes into account the recipient's reputation. So if you cooperate against a good person or if you cooperate against a bad person. And third order norm is actually what I told you before. if assessments depend on my previous reputation, what I do, and the recipient's previous reputation. And now you could even do this further, like you could also look at fourth order reputations, where my new reputation also depends on my previous reputation, like the reputation that I had immediately in the past, and this kind of stuff. So you could make it arbitrarily complex. But actually what this paper is about is that the fourth order doesn't help anymore. Like it doesn't give you more cooperation, it just makes everything more complex.
Okay, so stern judgment is the red one.
Yeah, that's right. Stern judging is this very, like among all the ones who give you high cooperation, stern judging is the simplest one. Yeah, that's right. Yeah, or as much. Like I'm not sure whether these blue points are above or below, but yeah. All right. Okay, so now we actually come back to this point that Jonathan raised at some point. So one strong assumption in this model on the leading 8 is that all relevant information is public and there are no perception errors. Yeah, sorry. That's right. You can look at mixed strategies. You would find some additional Nash equilibria among the mixed strategies, but there is no indication that they would do any better than the pure strategies. There are papers that do like the Nash equilibrium characterizations for the mixed strategies. There are no papers that I'm aware of that do evolutionary processes for mixed social norms. All right, so back to this strong assumption. So this assumption is that everyone observes everything, and I never make an error in my perception. So if Jonathan happens to cooperate with someone, I always see that this was really cooperation. There are no ambiguities. And one way how to represent such a situation is by looking at what is called an image matrix. So an image matrix is just an n by n matrix, and the entry Mij is 1 if and only if I think that person is a good person. So Mij is 1 if and only if I think person J is good. And so one way how to represent the situation is like this. So this is my graphical representation of an image matrix. So this is a population that consists of 4 individuals. If person 1 thinks, if person 2 thinks person 1 is good, I mark it as blue. If some person thinks that, if the role player thinks person 1 is good, I mark it as blue here. So obviously person 2 thinks person 1 is good. But also in this case, it happens to be the case that person 2 thinks person 3 is bad. Yeah. So in this case, it actually happens that person 2 is aware that person 2 is a bad person. I mean, yeah. I mean, you might want to argue that at least the diagonal, it should always be blue, like that would be a natural assumption. Like, but actually in this model, that's not what happens. In this model, what happens is that if I think I'm a good person, everyone would agree I'm a good person. So that's actually why you see these columns here. Like if person 2 thinks person 1 is a good person, everyone else would also think it's a good person. All right. And you might think this is a rather strong assumption because like usually like even if I think Supratim is a great person, like perhaps some of you know information about Supratim that I just don't know. And perhaps therefore you think it's unlikely. Therefore you think he's a bad person. Could be. And so the question is, like when there is private information, or if it sometimes just so happens that I might misinterpret what happened, like perhaps Jonathan cooperated with Supratim, but for some reason I interpreted it as a defection. Then like you don't see these perfect columns anymore. Like still you will see some correlation of some kind. Like for example, if you see here a blue square, it becomes more likely that the other squares are also blue. But there is no perfect correlation anymore between the different people's opinions. And now there are these disagreements. Suppose you start in a population where there are a few initial disagreements about others. Now the question is, would over time people converge to a unique view again, or would these kinds of disagreements spread? So in some other sense, you could ask, like, is the social norm that you consider error correcting? Like if you start with some small error, some small disagreement, would these small errors lead to further disagreements, or would these disagreements disappear over time? All right, so this is actually what we explored in the paper. So what we do there is we consider, again, a population in which players now assign reputation based on private and noisy information. So how it works is, again, people randomly are matched and they play games, but then not everyone observes these games, so there's only a probability Q that I might observe a third-party game. And also, even if I observe the game, with some small probability epsilon, I might misperceive what happened. So even if you cooperate, I might interpret it as a defection. And for simplicity, like if we would do this correctly, of course, we would have to do this for all 4,096 norms. If you are interested in third order norms. To make things simple on us, let's for the moment only consider 3 possible norms, like all D, all C, and one of the leading 8 norms. Like pick one of them, and we compare it to all D and all C. All right, and also, we assume that initially, we just assume that this whole big square, everything is blue. Like everyone thinks of everyone as a good person. All right, and then the question is, if you just simulate the reputation dynamics, like you just randomly let people play against each other and you let randomly people observe each other, and then you let people update their reputations, what is it that you will get in the long run? Yeah, so in other words, how do the population's image matrices evolve in time? And so we did these kinds of simulations, and for simplicity, what we assumed is that the composition of the population is fixed. Like I believe in these simulations, it's something like 90 individuals, and 30 of them play all D, 30 of them play all C, and 30 of them play one of the leading 8 strategies. And then you let them play this game against each other, and you're interested in how does the image matrix look in the long run. Yeah.
Is it the difference between their social norms, or it's the difference between about the reputation? Because I thought that
Yeah.
the picture of blue and the white, so basically it is saying that who thinks that I'm a good person.
Yeah, that's right.
That's not saying anything about what social norm I am.
That's right.
But the strategies here you are choosing is the one is about the difference in the social norm.
That's right, yeah. So actually, like in this quest that I previously showed you, like there were differences between the players. And I didn't make it, like these differences could arise for 2 reasons. Like A, because this person really did a bad thing. But B, it could also happen that I have a different social norm than you have. And therefore, I might think that this behavior was really bad, but you might think that this was a perfectly legitimate behavior.
So it's like that GDP, I am assuming it to be good, but like someone is...
Yeah. So that can, for example, now happen in this case. Like, for example, all C is the social norm that always assigns a good reputation to you. But for example, a leading 8 norm would not always assign a good reputation to you. All right, so if you just put this into computer and let the computer simulate, so this is what you get. Things are a little bit complicated. Please be patient. I try to explain things. So there are 8 different big squares because there are 8 leading 8 norms. But perhaps we can focus here on the upper left square. So what happens here is like there are really 90 individuals here, I believe. The first 30 play L1, the second 30 play all C, the third 30 play all D. And now 2 things are trivial, like all D, this is just how I define things. They think of everyone as bad. Okay? Now the 30 all C players, they think of everyone as good. That's also just by definition. The interesting thing is, what is it that the leading 8 player, here the L1 players think about each other? So what you see here is that most leading 1 players actually think of all D players as bad. Like in most cases, it is actually true that leading 1 players think in the long run, all D is a bad behavior. Also, most players believe that all C actually deserves a good reputation. And also, like most players believe that other L1 players actually deserve a good reputation. Like not every one of them, like you see these white dots, this is because there are, for example, these perception errors and this incomplete information. But this is the kind of general pattern. And this, by the way, is perhaps also what you want. Like what you want to have for a really strong cooperative norm is that the norm against itself, they realize they are good people, perhaps even that the norm realizes all C are good people, but you really would like the norm to be able to single out all D. All D is a bad behavior, and you shouldn't assign good reputations to all D players. Okay, so this is in general how you need to read these squares. Now, if you stare at these squares for long enough, there are a few patterns that you might realize. So one interesting pattern is that there are 4 out of these 8 social norms, they fail somehow to assign a bad reputation to all D. Like there would still be a very good proportion that they look at an all D player and think, oh, this all D player is a good person. And now if you think about what do these 4 social norms have in common, they do have in common that if they see a bad person defecting against a bad person, they think it's good behavior. And now if you see all D, like there's a very good chance that they would defect against another bad person, and at that point they would get a good reputation. So this perhaps is one interesting thing to notice. Another interesting thing to notice, I hope it's somewhat clearly visible, like there are always these instances where leading 8 norms think of their own kind as bad. Like, although, like here there are these white lines in these squares. And that is also a surprising thing. Like, how can that happen? Like, if they play against exactly the same norm as I do, like if I'm a leading 1 player and I see another leading 1 player, why would I sometimes think this is a bad person? And it happens exactly because disagreements can spread. So how does it happen? Suppose I start with a good reputation, but for because of some error, I think that Supratim is a bad person, although everyone in the room agrees that Supratim is a good person. Now, because I think Supratim is a bad person, I might defect against Supratim. And from your point of view, it will look like I defected against a person who didn't deserve defection. So you will think I'm a bad person from now on. So this is actually why you get these white lines in here. And by the way, you get nothing like that in a public information model. So in the public information model that we had before, just the upper left quadrant would always be perfectly colored. Okay? And another interesting observation is that there are 2 norms that just do not work at all anymore. So there is this norm L8 that in the long run just assigns a bad reputation to everyone. There is also this norm L6 that in the end is just random noise. Yeah, that's exactly the interesting thing. I told you before that in public information, one of the most successful norms is stern judging, and even kids might play stern judging somehow. But it turns out once you allow for errors, stern judging is actually a very bad norm in the sense that it's really bad in maintaining cooperation. Exactly for this reason, because stern judging has really strong opinions of what you should do. And once there are small disagreements and you have strong opinions of what you should do, it's easy to have further disagreements. All right, so the overall conclusion from this is like this kind of noise seems to make it harder for cooperation to evolve. Also, like you see this interesting phenomenon that even if you both actually adopt a norm that actually is a good norm, like a norm that tries to sustain cooperation, I might think of you as a bad person just because of a random error. And these errors can spread, like these disagreements can spread. Yeah, and we also saw that some norms fail to maintain cooperation altogether. Like, for example, the stern judging, like it's no longer possible to maintain full cooperation with stern judging. And it actually turns out, like, I guess for these simulations, we used a certain parameter value, like the error rate is 5%, something like that. But you would actually get the same picture, like for stern judging, you provably get the same picture for any positive error rate. So in the end, with stern judging, you always get this random noise in the end. And so the previous picture was kind of static. I just kept the norms fixed that people use, like a third would use a leading 8 norm, a third would use all C, a third would use all D. Now you could also do evolutionary simulations on top of that. What you would see is that some norms still give you some cooperation. So for example, L2, if you do evolutionary simulations, like you would see that for some benefit values, still L2 gives you something like 70% cooperation overall if you do these kinds of simulation. But most social norms would fail. Yeah, so what should we do about it? So obviously, like, I mean, you might think that, I mean, obviously, to me, it's quite obvious that we use something like social norms to evaluate each other. So it's not that indirect reciprocity is just an abstruse model that is good for nothing. So in my opinion, we do these kinds of judgments, but still, like, indirect reciprocity alone would have a hard time to explain why we even incorporate. So then the question that you might ask is, okay, what is missing in these models? Yeah, please. That's right. In the previous graph that I showed you, that was exactly the case. In this graph that I show you now, this graph here, actually people were allowed to update their strategies over time. So again, there would be a process on 2 time scales. On the short time scale, they just play against each other. These image matrices evolve, and you use these image matrices to compute each person's average payoff. And then based on these average payoffs, I might occasionally actually revisit my social norm. Would I really like to play L1, or would I rather like to be an all D person instead? And then if all D gives me a high payoff, I would switch to all D. And the result of this kind of simulation you see actually here. So if you run this kind of simulation, this would tell you how much cooperation do you see on average. Yeah, I mean, that's a very good point. So again, what I did here is I always picked one leading edge strategy in all D and all C, and then I did evolution. You might ask yourself, okay, I mean, perhaps that's restrictive. Like, obviously, people could choose completely different norms. Like, they're not restricted to choose this one leading 8 norm. So you could, for example, let all 8 leading 8 norms evolve together with all D and all C, and perhaps even with image scoring. I don't think this particular thing has been done. What has been done is that people actually try what happens if you allow for all 4,096 third order strategies. Now, this is actually really a lot of computation work. So I wouldn't be able to do it, but there are people out there who have supercomputers. So Yosuke Murase did this, and he has access to the supercomputer in Japan, in Riken. And yeah, he used the supercomputer to do these kinds of simulations. And also, when you use all 4,096 strategies, you would get an even more pessimistic picture than you get it here. They did it for private information and errors. That's right. If you have a very long simulation, like you record which proportion of interactions resulted in cooperation. All right, so what are possible solutions? And so people have thought quite a bit about what are possible solutions. Like, what is this simple model of reputations missing? And one possible explanation, one possible idea that you might have that the simple model is missing is empathy. So what is meant by empathy? So for example, I might think Supratim is a great person, but now I see Jonathan defecting against Supratim. I mean, one thing that I could conclude is now, therefore Jonathan must be a bad person. But another thing that I could do is, wait a minute. So Jonathan defected against a person where I wouldn't have expected it. But perhaps Jonathan has good reasons to act. Like, from his perspective, perhaps it makes perfect sense. So when I evaluate what Jonathan does against Supratim, I don't evaluate based on what I think of Supratim. I evaluate you based on what you think of Supratim. And if you thought all along that Supratim deserves it, then I'm perfectly fine with it. So that's what this paper does. I mean, that is a good question that I can't answer. And a question that I can answer is, like, why is it even beneficial in this kind of model? It's beneficial because it kind of gets rid of these kinds of disagreements.
But there could be some private information, like in the sense, maybe he knows something which you don't know.
That's right. Yeah. So in some sense, it actually makes perfect sense to have empathy.
Jonathan's image in your perspective is already good, so that is also a thing which.
That's right. Yeah.
That I know he's a good person.
That's right. But that's actually not part of this model. But that's actually a very good point. Like I might have empathy for those people who I believe are good. I might have less empathy for people who I already believe are bad. Yeah. So this is one possible.
So in these cases, have people tried to include Bayesian updating of your beliefs about person and all that?
There are one or two papers I'm aware of that work with Bayesian beliefs, but in general, like beliefs are not really carefully modeled in these kinds of models. Yeah. Another thing that you could think of is, like in some cases, you might actually think there are public institutions out there that help me tell what your reputation is. Now, for example, one example would be credit ratings. So if I want to know your credit rating, like either I observe you, or I go to this public institution that will tell me there is this public record of how you've behaved in the past with respect to your finances. So you could imagine that there is this institution out there that tries to like synchronize people's opinions. And I could either decide, for example, it could be also the leader of your tribe. So there could be this one designated person in your population that you just, whatever this person says, you take it. And if this person says that Supratim is a great person, I just accept this. And also like you can do models that ask, A, if there is such an institution, does it help cooperation or not? The answer is it does. B, if you're not forced to obey to this institution, but if you have a choice actually to listen to this institution or not, would you learn to listen to this institution? And also there they see there is some evolution towards listening to this institution. All right, there is another possible thing that you could think of, which is gossip. So if I see Jonathan, for example, defecting with Supratim, I might just go to Jonathan and say, hey, what was up? Like, yeah. So that's perhaps is the most obvious solution of all these problems. In fact, it's almost so obvious that you ask yourself, so why did people even bother to look at this old model without any gossip? And again, usually, like, perhaps there are two explanations. Like the first is perhaps it's mathematically a little bit more clean, and like you make fewer assumptions and fewer rules. Also, like, I mean, as so often, it's the easier model to analyze. That's right. Yeah, that's right. Yeah. That's right. But still, I mean, how gossip actually works in these models is as follows. Like you would have a plain vanilla indirect reciprocity model, plus there is an additional stage. So every once in a while, like you form a group of 5 people, and then all of them are asked, okay, what do you think of Supratim, for example? And then you see, oh, 4 people in my group think he's great, only 1 person thinks he's bad. So probably it's best if we all think he's great. So this is how it is implemented in these models. Would switch. Yeah, that's right. So obviously, these kinds of models also have the effect of reducing disagreements between individuals and making it harder for disagreements to spread in a population. That's right. Yeah. That's what they all have pretty much in common. Yeah, another way how to look at actually at these mechanisms, and you can make this a little bit more general, like they all have the effect of synchronizing opinions. And you can, like this is now something that you can show mathematically, like you need some kind of synchronization between opinions, otherwise it's impossible to get cooperation between indirect reciprocity. So you need something like, if Alice thinks Bob is a good person, Charlie needs to have a higher likelihood to also think that Bob is a good person, like higher than neutral. So, yeah.
So all these solutions you are suggesting, they are very human-centric.
That's right.
But in
That's right. There are a few species where people think this might be indirect reciprocity that is going on. But my impression is also that people are not entirely sure whether it's really indirect reciprocity. All right, so this is actually everything that I wanted to tell you about indirect reciprocity, a special kind of social norm that helps you cooperate. Now, for the last 15 minutes or so, yeah.
Like, is it also possible to think of certain institutions which punishes defection? I mean, not would that come under this adherence to public institution, like the legal system punishes defection, or some such thing can also enforce cooperation?
Mm-hmm. Okay, there are two things in your question. So the question is about how can we get punishment into this picture. So there are two answers to this. Like the first, like there are models out there that do not even have something to do with indirect reciprocity. They just look at cooperation and punishment, and whether this alone would help. And these papers then show under certain conditions, not always punishment can actually help to sustain cooperation. And so this is one class of models. The other class of models actually tries to integrate punishment here with indirect reciprocity, because a relevant question that you might actually have is like, okay, now we know how we should evaluate people who cooperate or defect with each other. But then you could have an entirely new set of questions. Like if you see a good person really punishing, like really hurting a bad person, would this be something good or bad? Or like, now this makes things a little bit more complicated even. There are a few models out there that do this. You get a lot of more social norms that can sustain cooperation. So you wouldn't have leading 8 anymore. You would have leading 1,000 or something like that. But yeah. Yeah.
How does the stern judging pair with these additions?
The short answer is very good. So for example, like, yeah, so these institutions and this gossip model, perhaps not this gossip model, but another one by Joshua Plotkin and colleagues, they show once there is gossip, you have a lot of stern judging around. Yeah. So just to make sure I understand, so you have a model in mind where there are perhaps two types of players, one are rich and one are poor, and you could take this into account in your social norm. So like, for example, if you're poor and you're defecting against the rich, that is acceptable perhaps, but if you're rich and defect against the poor, that is a really bad behavior perhaps. Yeah, I'm not aware of any such model. But it sounds very cool. Yeah.
One wonders about if you could expand the strategy space, because playing deep has a punishment effect, but it also has a first order benefit.
That's right.
In terms of immediate payoff. If there's a third strategy punishes without having an immediate benefit.
That's right. Yeah, that's right. It makes some interpretations actually easier, because like it's true, like if you defect against you, like there are two possible interpretations. I just wanted to save the cooperation costs, or also perhaps I thought you deserve it, but yeah.
So you have to trade off that first order benefit that people might get against the possible loss in your own reputation against.
That's right. Yeah. That's right, yeah. Yeah, so there are a few models out there that include punishment in the set, like obviously the strategy space becomes even much bigger or so. There are models out there that at least do the public information case with punishment. Doing it with private information, I'm not aware of any paper that does that. Yes, please. Yes. That's right. I mean, it's true, like in this model, everyone in principle can have different norms. But like if you run the evolutionary process on these norms, it might very well happen that in the end, everyone chooses to adopt the same norm. So it would, for example, it might be an equilibrium. But it's also true that there might be more than one equilibrium. Like, for example, Austria might evolve towards the L1 norm, but for whatever reason, India evolves towards the L6 norm or something like that. I mean, that sounds very interesting, but I wouldn't even know how to model this at the moment.
So that's where I think my question was that you can have different institutions which are more or less effective in punishing people for their defection or crimes or whatever. So societies where institutions are more effective in imposing such punishment.
Yeah.
There, I mean, because cooperators will realize more of their benefits.
That's right. Yeah.
So that may evolve towards the higher proportion being
Yeah.
cooperators, that sort of thing.
Yeah. Yeah, that sounds very interesting. Yeah. Yeah. All right. So this is everything that I want to tell you about. Yeah. Sorry, there's more that, about indirect, I suppose. Yeah. Yeah. Yeah, this is not how the model works. So it's not that after the fact, after you've seen something happening, that only then gossip would happen. So how it works in that model, gossip happens actually before players make an action. That's right. Yeah. I mean, how it works is like every once in a while you would form these gossip groups of 5 random individuals. They would exchange their ideas of what they think of some random individual. And then you would just take whatever is the majority. No. Yeah. All right. Are all questions with indirect reciprocity solved? I mean, perhaps you have some further questions later on. Yeah, so for the last 15 minutes, I wanted to tell you about some other model, about some different social norm, just to give you an impression that social norms can also be a little bit more subtle, perhaps. So the social norms is now about humility. The idea here being like, what is indirect about indirect reciprocity is that what you really should do is, like, if you do a good thing, you should do it publicly. Like, you should let everyone know that you just did the right thing. That's actually how these indirect reciprocity models work most optimally. And actually, like, you see similar points being made in different kinds of models. Like, for example, if you want to really tell people that you're a rich guy, I mean, the best way to show it is if you have bags like this. Okay? So if you have something good about yourself, like something that you think yourself is a good trait, like, you would think naively, like, you have every incentive to show it to everyone. But nevertheless, there are often social norms out there that would tell you that you should be humble. Like, you shouldn't brag all the time. It's weird if you brag all the time. And just to give you some examples, like one example, for example, is anonymous donations. So if you believe in indirect reciprocity, this would tell you, like, if I donate to a charity, I should always do it in public, because, like, there's really no point in doing it anonymously. But still, like, there are a lot of people donating anonymously. So, for example, there is this online database that lets you, oh, yeah, unfortunately, you cannot read this. But there's this online database that collects actually the big donations, for example, to charities or also to universities, and you can look, okay, what are the donations there? And you can actually search for a donor, and one possible donor there is anonymous. And if you look for anonymous, so the numbers that you would see here is something like 50 million to some arbitrary college. And then the question is, like, why would people do this? And does anyone have an idea? Why would people donate anonymously?
you are playing somewhat virtuous game.
That's right.
So thereby revealing your name, in a way, you are actually like failing in that way.
That's right. Yeah. But why actually do we have this sense of virtue? Like, why do we think it's a virtue not to tell everyone that you donated just 50 millions to a university?
Maybe again, like the norms that we like told to us.
Yeah. It's not entirely clear. Yeah. And I mean, also another possible answer that you could give is, I mean, even if I give 50 millions to Harvard University, for example, I don't want to get a call from Berkeley next day. Oh, by the way, I see you have money. Why don't you donate also to us? And I mean, that's true. That is definitely a reason why you would like to donate anonymously, perhaps. But also, like, keep in mind, if I learn about you that you donated to Harvard and you did it anonymously, I slightly think you are slightly better. Like, I think it's very virtuous of you. So we seem to feel that anonymous donations is slightly better than just open donations. Yeah.
One idea that immediately strikes me is like this, at least in this analytical case, this concept of envy, right, between people.
That's right.
If I have, say, excuses, maybe showing it or making it obvious would heighten the difference between people, which might cause excessive envy. I think it's probably something that I don't want.
Yeah, that's right. I completely agree. Again, you might ask the question like, why do our feelings work that way? Like, why would I feel envy of you if you just donated 50 millions to Harvard University? Yeah, that's right. No, I totally agree. But still, it's not entirely clear why our emotions work the way that they do.
Really many explanations for this type of thing. I mean,
That's right. Yeah.
Signaling to a smaller group of people that I'm very wealthy, but I'm not wealthy like that guy who's just flashing it around, right?
Yeah.
He's new to the game.
Yeah. That's right. Yeah. Yeah. Please.
There's also the possibility of, let's say, you think I am X levels of virtuous, but if you find out, oh, this guy actually did something which I don't know about, then you don't know how many other things which you don't know about that I've done. So there's also like a delta of you're saying in your head, okay, I think it's X, but the expectation that I have of things that I have not seen is also like, increasing it a bit, right? Like, for example, let's say I hear, oh, you didn't, let's say, anonymous donation, I somehow find out that was you, I say, oh, then how many other things do you have which are good, which you have not told me about? So now actually, because it's based on your imagination, it can go up even higher than it might actually be.
Yeah, I really like this argument. So your argument, let me rephrase it, is a little bit like that. Like, perhaps it was anonymous, but perhaps there's always a chance that I might find out. And once I find out, I'm really impressed. Like, then I start thinking, oh, what are all the other good things that you do and that I don't know nothing about? Yeah.
Sometimes it may happen that actually I feel that I should have donated more.
Yeah. It doesn't deserve to be public. Yeah, okay. Yeah, I get it. Yeah.
Harvard will know, right? Who donated it? Harvard will know.
Harvard will know. Yeah, that's right. Like, even if it's anonymous, there will be some people who actually know.
Person's son was or daughter was given admission.
That's right. Yeah.
It's not anonymous. I mean, by donating 50 million to Harvard, you're showing you don't understand where you're getting the good marginal benefit for your donating your money, right?
Could you expand?
I mean, because Harvard is not constrained in its spending, right?
Yeah.
I mean, it's effectively, it's kind of practically, it's a huge hedge fund with the university attached.
That's right. Yeah.
And so, in some sense, if you donated 50 million to Harvard, it would be expressing a very strong, like, moral, in some sense, preference for Harvard over donating it to somewhere else that you would have a much higher marginal benefit from getting 50 extra million. So
I completely agree. Perhaps the example is a little bit ambiguous. We shouldn't use this example. Yeah, that's right. We should rather use an example where I donate 50 million to some NGO that fights malaria in a very effective way. Yeah. Yes, please.
Of course, you'll have to show it off, but what if it would be a way to sort of better your own outlook of how you think you are as a person?
Oh, you're particularly proud of yourself because you did it anonymously. You didn't do it for the fame.
No, it would help me convince myself that I am a good person.
That's right.
So when people defect against me, I can automatically consider they were the bad ones because I'm doing these anonymous donations.
Yeah.
Allowing me to sort of, judge other people by making myself feel superior.
Yeah.
Improve my self-image in the sense, in my own eyes.
That's right. That's right. Yeah.
Convince myself that I did not deserve that affection.
That's right. Yeah. If you got a defection, you can convince yourself, well, there are so many good things about me that the other person just doesn't know about. Yeah.
Or maybe they are smart enough to like reveal the group which matters actually.
Yeah. I really like this discussion. So either way, like to make it short, like I hope you all agree with me that this is actually an interesting phenomenon. Like, and there are many ways how to think about it. So anonymous donations is one example. Also, avoiding to brag about your latest high-impact publication is another example. There is another interesting example. Like I showed you this Gucci bag, and I told you why there might be reasons to walk around with this Gucci bag. It turns out there are other bags out there, like this one, that happens to be even more expensive than the Gucci bag. But it's really hard to see that this other, like at least to a naive person like me, it's really hard to see that this bag is a very expensive bag. So it loses all signaling value to me. So the question is then, why would you spend, like if having these expensive bags is all about signaling wealth, why would you buy an even more expensive bag that actually has a lower signaling value? So this is another variant of this question. Yeah, please. That's right. Yeah, that's right. And I believe we are thinking similarly. And so what I'm going to do is I propose to you a model, and perhaps you will see your ideas reflected in this model. All right. Okay, so this is the question. Why pay a cost to do something good or to be great, and why then hiding the cost? Why do you do something which is really nice and then don't tell people about it? So this is how we modeled this thing. We call it the signal burying game. So it works as follows. So as opposed to previous, all the time I was working with symmetric games, like the symmetric business lemma, this is no longer a symmetric game. So this is an asymmetric game. It's a signaling game, if you know this kind of literature. So it's an asymmetric game between two players, a sender and a receiver. And also in this type of literature, what you usually need to assume is that like there are some heterogeneities between players. Like it's not that all senders are the same, but rather there are different types of players. Like high types, they have really high quality. Medium types, they have medium quality. Low types have low quality, for example. And also receivers, they can either be discerning or undiscerning, so either very choosy, they would only like to interact with high senders, or they can be more generous, like undiscerning. They would accept high and medium senders. And the important thing in these types of models is whether, if I'm a sender, I know whether I'm high, medium, or low, but the receiver doesn't know. So for example, if I apply to university, I want to be a professor there, I have an idea how great I am, if I am at all. But the university doesn't know. Like I need to convince them with signals. And now how the model works is like senders can choose whether or not to pay a cost C larger than 0 for a good signal. Like the signal that you produce is unambiguously good. Like for example, donating to charity. Like everyone would agree this is by itself a good thing. But once they've paid the cost for the good signal, they can decide whether or not to bury this good signal. So what does it mean to bury a good signal? It means that like if I don't bury a signal, like if I send a clear signal, everyone will learn it. But if I bury a signal, it will only become known with some probability R. So with some probability R, you might learn anyway, oh, by the way, this person did actually this good thing, but decided actually not to reveal it. And with probability 1 minus R, it looks to you as if I had done nothing. So with probability 1 minus R, you would think that this person didn't even donate to a charity. It just means 3 different qualities of senders. Like what I mean here, like for example, an example that you could keep in mind is senders might be applicants to a university who want a university job. And I can either have very good skills or medium skills or low skills. And the university needs to decide, would they like to accept me as an applicant, or would they like to reject me?
So, say even a low type can choose to spend a cost, and even low type can vary the signal.
In principle, they can. Just it might often be the case that the cost is too high for them. Like often what you assume in these models is that low people in principle pay the cost, but it just doesn't pay for them.
So it makes like in equilibrium only like high type might pay, and they only choose to vary on.
That's right. That might happen. That's right. So we make the model here, like you could also just assume it's R, but we allowed the model here to be a little bit more general and assume that the revelation probability might depend on your type. For example, like if I'm a Nobel Prize laureate, like it's very likely that you will find out that I'm a Nobel Prize laureate, like even if I don't tell you. So if I'm really good, like it might be more likely that you can actually see my buried signals.
So by varying the signal, you actually make the cost of it different across the types, and thus you can use it.
That's one reason why you might see burying. Yeah, that's right. All right. Yeah, and the last step then is like, so receivers would see the signal that you send, and then only based on the signal, they would decide whether they accept you as a partner or not accept you as a partner. And the rule here is that senders usually, so the payoffs would be in general AIJ for the sender. Like it depends on my type and the receiver's type. And the payoff is BIJ for the receiver. So it also depends on the sender's type and on the receiver's type. You would usually assume, like you would make some assumptions on these payoffs, but I don't want to go into detail. Usually the assumptions are that senders would always prefer to be accepted because that's a good thing, like they want to be accepted. But you would also assume that the receivers don't want to accept everyone. So they really would only, like the discerning types really only would, the really choosy receivers would really only like to accept the high types, and the not so choosy receivers would be fine with high types and medium types. All right, so this is the game in an illustration. So there are 3 different types, high, medium, and low. These are the senders. Senders can do 3 different things, like they can either bury your signal, they can send a clear signal, or they can send no signal at all. Like if I send a no signal, it will look to the receiver as I sent no signal. If I send a clear signal, it will look to the receiver as if I send a clear signal. But now if I send a buried signal, there can 2 things that can happen. Like either my buried signal becomes revealed, like the receiver somehow learns that I actually sent this buried signal. So then it really looks as if I sent this buried signal. But if the receiver never learns that I actually sent this buried signal, it looks to the receiver as if I sent no signal at all. And so this is in principle the game. And then the receiver, each receiver type can decide, would I like to accept this sender or would I like to reject? But now the interesting thing is, like, you can prove that under some conditions on these R's and AIJs, that this is the equilibrium that you would get. Like you would get what is sometimes called the separating equilibrium, where really the low type, they really have no incentive to pay a cost. The medium types, they still try to distinguish themselves from the low type, so they would send a clear signal. And the high type, they would still like to try to distinguish them from the medium types by sending a different signal, in this case a buried signal. This has 2 effects. The one effect is, like, if people realize they are actually, they have sent a buried signal, they wouldn't only get access to those receivers that are not so choosy, they would also get access to the super choosy receivers. But there is also this risk, like with some small probability, people do not even realize that you did the right thing, and then you get accepted by no one. So it's kind of, by sending a buried signal, there is kind of a trade-off. Like you risk that some undiscerning receivers will reject you because they never learned that you actually did the good thing. But on the other hand, the potential gain is if people find out that you actually did the right thing, you might get even access to even better receivers. Yeah, so let's go back to our example with the anonymous donations. So how could this make sense of anonymous donations? So one explanation that you could give now for anonymous donations is that like anonymous donations make a lot of sense if you really don't care what the general public thinks about you. So if they learn whether you donated 50 million to Harvard, you really don't care. You only care what, for example, your family thinks of you or your spouse thinks of you, and they will find out anyway. And a simple explanation you can give here with these handbags, like with a brand handbag, you signal wealth, but also you signal that you're really desperate, that everyone learns that you're rich. And you're really not very choosy in who you want to impress. With this more subtle bag, you really signal not only that you're wealthy, but you also signal that you really only care about people who have a sufficient knowledge of fashion. All right. Yeah, and I mean, as usual, like here I did tell you like the equilibrium perspective, but you could also do evolutionary simulations about this. And then you would see that if the parameter combinations are all right, you would see that this kind of burrowing sometimes evolves. All right, so we are done. So what I wanted to convince you of is that like these models of indirect reciprocity can explain why cooperation evolves, even if you don't meet each other repeatedly, just through repetitions. And also what I hope I could convince you of, like there's actually this interesting dynamics going on the space of image matrices. Like if you are a math geek, it's actually quite a nice object to work with. Also, what I try to convince you is like once you have noise in these reputations, like cooperation seems to become more fragile. But the good news is that this in turn might actually give you some incentive to do things that we do anyway, like to do gossip, for example. And the last thing is that like social norms can also be rather nuanced. Like for example, I would say this preference for humility, for example, is perhaps a rather nuanced norm. And I guess I just wanted to expose you to some other kind of model that makes sense of this kind of norm. Okay, that's it. Thank you.
So this reminds me a bit of, and we're probably most familiar with the idea of burning money to signal a time. Yeah, you walk into the nightclub, you burn a stack of a few $100s just to indicate that you're rich. You must be, because the marginal value of money is low to you, so you can afford to burn it. So here it's a bit like varying your signal is like burning money.
But in private.
And the different, and rather than have explicitly a different marginal value of money to yourself, you have the differential cost in the differential chances of not being discovered, of your signal not being observed, right?
That's right, yeah. Yeah. Yeah.
I don't know if that analogy helps me.
Yeah, that's right, yeah. By the way, I only presented you with here the most simple setup. For example, like the revelation probability in this model only depended on the sender's type. You could also think of models where the revelation probability of my buried signal also depends on the receiver's type. For example, with this example of anonymous donations, like most likely my family will know this because for them there is a very high revelation probability. And you can see that once you have actually that this revelation probability also depends on the receiver's type, it's even more likely that you get this burying equilibrium. Yes? Oh, yeah. Yeah.
So what happens when you sort of reduce the cost of the signal? Do the low and the medium senders also start to do this burying signal?
That's right. So one assumption that we put into our model is that for the really low type, it just never pays to send the signal. If you now make the cost of sending the signal very low, then suddenly also the low types would start sending the clear signal, for example, and this might destabilize the equilibrium. So I would have to look at the exact equilibrium conditions, how things depend on C, but in principle, like lowering C could mess up with this equilibrium.
So the recipients will essentially not get enough information.
That's right, yeah. I mean, in particular, if C is 0, everything is just cheap talk.
Yeah, exactly. And then what about the probability R of it being found out?
Yeah.
If this were higher, is the receiver also still getting the same information?
It turns out it cannot be too high because, like, for example, if this probability happened to be really 1, it means you do not bury your signal, like, because it becomes known anyway. So it needs to be strictly smaller than 1, so it needs to be small enough to work.
So when it's like tending to 1, does it, the burying signal essentially become a clear signal? And then does that mean that a recipient cannot distinguish between a median and a high class individual?
That's right. Like once you do not have once this burying equilibrium can no longer work, for example, because R is close to 1, people will settle at another equilibrium. And for example, one equilibrium that might arise is where the high types and the median types just send a clear signal, and the low types send no signal at all.
Okay, so I don't know what the public perception of my reputation is.